You will be asked to use electronegativity values to classify a bond. And when I say classify a bond, the typical classifications are a nonpolar covalent, although sometimes that is also called a pure covalent. It depends on where a particular text is cutting the line between nonpolar and polar. Polar covalent or ionic. We use electronegativity values to do this, and here's why. What electronegativity is it's a measure of how hard something is pulling on an electron. We already know that electronegativity increases as we go up and to the right as one of our periodic trends. Fluorine having the highest electronegativity on the table. That means when it's bonded to something else, it's going to pull harder on electrons. If we look at, for example, oxygen bound to fluorine, we see from these different electronegativity values that the electrons will be pulled harder by fluorine than they are by oxygen. We call this a polar bond. If I look at the difference instead between something like sodium and fluorine, it's a much bigger difference in electronegativity. And in fact, they share so unequally, fluorine pulls so much harder, we say the electron's been entirely transferred and therefore calling it ionic. So what ionic and covalent are two categories we've used to split up what's actually a continuum. If we look at the difference in electronegativity values between two atoms, as we go up from zero, bigger difference, we're going to have an increase in polarity of the bond. Then we draw a line here at a value of 1.8. And we say if the difference in electronegativity between these two is greater than 1.8, we're going to call it an ionic bond. The bigger the difference in electronegativity, the more ionic the bond is. So for example, this question here, which fluoride is most ionic? Sodium fluoride, magnesium fluoride, barium fluoride, cesium fluoride. What I can do is that there's two ways I can solve this problem. The first one is I'm going to compare electronegativity values. Sodium is 0.9 and fluorine is 4.0. That gives me a difference in electronegativity of 3.1. Comparing magnesium and fluorine, 1.2 and 4.0. It doesn't matter that there's two fluorines. I don't need to take that into account. Gives us a difference of 2.8. Barium fluoride, 0.9 and 4.0 gives us a difference of 3.1. Cesium fluoride, 0.7 and 4.0, that gives us a difference of 3.3, classifying this as the most ionic of those. Another way I could have been able to tell this same thing is, since electronegativity has a trend of going up and to the right, then I know that the farther apart two things are on the periodic table, the more ionic the bond will be. So those are where the location of the four things were that we were talking about in that problem. Which one's farthest from fluorine? Cesium. So it's going to have a difference in electronegativity most different from that of fluorine, therefore making it the most ionic. You can also use electronegativity values to decide which bond is more polar. Polonium and oxygen, phosphorus and oxygen, or aluminum and iodine. So finding my values, phosphorus has a value of 2.1, oxygen 3.5. I need to grab values for aluminum and iodine. 1.5, 2.5. So which one's more different? This is a difference of 1.4. This is a difference of 1.0. This is a more polar bond.